Okay, so thank you for joining us in class today. I think we picked a good day to switch to remote. I don't know if you've been outside, but it is freezing and icy and terrible. So hopefully, I think we're supposed to get like 4 inches of snow tomorrow too. So you have that to look forward to. Let us start. Liam asked a question real fast. How do you? So I know you can edit Verilog with Visual Studio Code, but can it be done in Visual Studio 2019? No, it cannot. Or certainly not without any like really serious hacking or craziness. Sorry you have to come to campus for a physics lab, Gailey. That's no fun. Yeah, respect. All right. Okay, so let's dig in. We are going to, like I said, we're going to spend today just kind of getting up to speed. We're not even going to really do anything serious in Verilog. But I'm going to go through the whole setup process. Disclaimer though, I'm going to go through the setup process in Windows because that's the computer that I have set up here in the lab. So that's that. There's nothing really I can do about that. That being said, I made a video for Verilog in Mac OS. Let me go and just copy it again. It's like 10 rows up in the chat from earlier today. Let me stick it back. If you're on Mac OS, go ahead and follow this. It's actually a lot easier to install Verilog or Icarus Verilog on Mac than it is on Windows. So that's another reason why we're going to focus on Windows today. So I'll give you just like a minute. If you're going to follow along, I recommend that you follow along with the process here, and we'll get everybody set up. There's going to be a lot of discussion. We probably won't get to it in the morning class. We didn't even get to Visual Studio Code because I'm going to focus on doing Verilog in Notepad because one of the things I want to emphasize is that Visual Studio Code is not. You don't install Verilog on Visual Studio Code. It's just a text editor. So I'm going to use Notepad actually to write Verilog today, and we're going to use the command line to execute some stuff. So let me pull up. I'm just going to use the regular sort of Windows command line here. And I had done a bunch of crazy stuff before in dir. Okay. Let me do that. So the first thing I'm going to do is make sure that I did in fact uninstall iVerilog. So some of you guys have already emailed me with getting these errors, right? iVerilog is not recognized as an internal or external command operable program or batch file. Basically, that means that iVerilog is not installed. So if you did everything and you were still getting this error, we're going to talk about the number one reason probably why you got that error. But fundamentally, it means that your program's not installed. I did this just now just to verify that I have, in fact, removed Verilog from my computer. And we're going to start from scratch as soon as Adrian and Connor are finished typing their questions. Do you have to install it on the same drive Windows is on? That's a terrifying question. Yeah, I would imagine so. Well, no, you don't. As long as you know, so Connor asks, do you have to install it on the same drive Windows is on? No, you don't, as long as you know how to set up your path environmental variable correctly. Yeah, you also have to like you need to turn the command prompt on and off. So we're going to go through all that right now. One thing I will say is, while you guys are typing your other questions, let's see, Windows on my SSD and I installed it on my hard drives. Got the not recognizer. Yeah, you got to make sure and tell Windows where it is. We're going to talk about that. That's like the 99% of the reasons why you installed it and it didn't work is because you didn't update the path variable in your operating system. Kaylee asks, can I still use Visual Studio Code? Absolutely, and we're going to use Visual Studio Code. I'm just not going to use it today because I want to sort of emphasize that Visual Studio Code and Verilog are totally separate things from each other. No, you can use Notepad++. Like I said, I'm actually not even going to use Notepad++. I'm going to use regular Windows vanilla Notepad to do the Verilog today. Just to illustrate that they're separate. Because we get, because they kind of, in your intro classes, you use like Visual Studio 2019 to do your C++, and you're using that integrated developer environment where everything is sort of like built in for you. And that's great, but you should know that that's not what's normal. That is not the usual. Usually you have to sort of install these tools separately on your own and get them to work together. And that's what we have to do here. So don't get too spoiled on your IDEs like Eclipse and Visual Studio 2019 and stuff like that. So anyway, let's chug along. Oh, I was going to say, I am not going to, you're going to see a lot of command line commands. I'm not going to spend a lot of time talking about how to use the command line. Because you guys, I mean, W's get kind of a pass because they can sort of escape this, but the computer engineers and especially the computer science folks, I'm going to assume a like basic level of computer proficiency, right? I'm going to assume that you know how to use the command prompt on a fundamental level. I'm going to assume that if you're using Mac, I'm going to assume that you know how to use the terminal kind of at a basic level. And again, you're going to see all of the commands that you need to know, we're going to see here, but you really should just be comfortable using the command prompt. So, all of that said, let's get going. We need to actually download and install Icarus Verilog. And again, I'm on Windows, so if you're on Mac, I apologize. Go watch that other video, and then we'll come back. Okay, so I'm going to flip over to Chrome, and the website here is iverilog.icarus.com. This is just like a placeholder where they have a bunch of the stuff. If we want to do an installation, we've got to do some traveling. So it says, where is Icarus Verilog? And it says, note. This is a quick summary of where to get Icarus Verilog. For a more complete download and install instructions, look here, and they provide a link. So we click the link, and it takes us to iverilog.fandom.com/wiki/installation guide. And if you're doing Windows, so this basically is the guide for installing iVerilog on any operating system in the known universe. And they put Windows all the way down at the bottom. So we're going to go all the way down to Windows, and it says Windows binaries wrapped in a handy installer are available from Pablo right here on this link. So it's bleyer.org/Icarus, and we're going to go ahead and grab the top one. This is the most recent version, 2020 08-24, so August 24th, 2020 for 64-bit Windows, setup.exe. That's what we're going to grab. It's going to download. I'm going to go to my downloads folder and double click to start the setup. Now it's going to pop up this thing and says, hey, this is malware, don't do it. But we really want to do it, so we're going to hit more info and then grab this run anyway button. And then let me switch back over to here. And now we're going to kind of click through the normal process, right? This is a pretty standard install. If you don't know how to install a program on Windows, then I don't know what to tell you. So hit next. It's going to install in your C drive. And this is if you wanted to install it somewhere else, like your D drive, if you're doing the SSD, HDD sort of setup. This is where that would live. We're going to hit next. Will I be fine with the 2019 version? Which version are you talking about? Are you talking about like this one that's below it? Like the 2019, what is that, 08-09, so August 9th. I would imagine so, probably. I can't think of any reason. I don't mean, we'd have to like read the change log to figure out what they changed. But probably. So if you find yourself having weird issues, you might uninstall and then reinstall the 2020 version. But I bet you'll be okay. Okay, so let's see. We're going to do this. We want to make sure to have these dependencies, especially this one, GTK Wave, is how we'll visualize our timing diagrams and actually see our simulation. So we would definitely want to make sure that's installed properly. Hit next. Hit next again. And then here is the most important part. If you installed Icarus Verilog on Windows and it didn't work, it's probably because you didn't do this. You need to check this box. Add executable folders to the user path. This will enable Windows to know, or the command line, the command prompt to know that iVerilog is a thing. So make sure that you check this box. Add executables to the path. If you don't do this part, it will not work. So make sure you do that. Hit next. Hit install. It's going to do the thing. And we're finished. And now I go and I type iVerilog, and it still says iVerilog is not recognized as an internal or external command operable program or batch file. This is because I had the command prompt already running before I did the installation. You need to just restart the command prompt after you're done installing. So now if I type it, I get an error from iVerilog, but it's iVerilog's error, right? So no source file, and it gives me a bunch of usage information. It says see the man page for details. So this is iVerilog throwing an error, but the fact that it does this means that it's working properly. It's installed, and we can use it to do the stuff that we want to do. So, any questions about that, the install process? All right, so let's go ahead and actually make some stuff. I'm gonna go ahead and navigate back to, so I'm in this my C drive, users, and my user folder. I'm gonna actually go ahead and go all the way back to my C drive. So the way to navigate places is CD, stands for change directory, and I wanna go back up some levels. I do .. I actually wanna go up 2 levels to get to my C drive. .. again. And now I'm in the C drive. And let's see. All right. And then if I want to view what's in the directory, I type dir or ls if you're on a Unix shell. All right, I can see all the stuff that's in my C drive. And I want to make a directory to hold the stuff. So it's mkdir for make directory. Liam asks, could I zoom the command window so it's a large? Maybe. Oh, look at that. Control zoom in. I didn't even know that was a thing. Dang. That's changing the game right there. Okay. So I'm going to make a directory, and I'm going to call it ECE 2372. Now, it's important to note, by good practice, you should not include any spaces in your directories. So for example, if I do that and then view my directories, look at this. I have a directory called 2372 and a directory called ECE. It created 2 separate directories for me. That's messed up. So by the way, if you want to remove directories, rmdir ECE 2372, and I can see that they are gone. Richard asks, what did you type to make sure it installed properly? It's just iVerilog. And you should get this if it installed properly. Okay. So let's see. I did rm. So if you want to create a folder with a space in its name, you got to put it in quotes. So I would say like ECE space 2372, but have it wrapped up in quotes. And then if I viewed the directory, it would be right here. But usually it's not a good idea to do that because the programs you're using might be running batch scripts that aren't doing that. So I'm going to remove that. If you want to create something that has kind of spaces in it, you could say make dir ECE underscore 2373. Use underscores as your spaces. But I'm just going to type it ECE 2372. And then I'm going to go into that directory. So I'm going to say cd change directory ECE 2372. Now I'm in. Hudson says that's the command. Yeah, so that means that you did not install it properly. So you know you're doing it wrong, Hudson. Did you remember to check the box to add it to your path and then remember to restart your command prompt? I don't remember. Well, then yeah, you need to uninstall and try again. But we are going to keep it moving forward. Yeah, just click all of the boxes. Check all of the boxes. Richard, I mean, you must have messed something up. Like there's, yeah. If you're still getting that error, then something's messed up. But we're gonna, and don't forget I have office hours today. If you want to sit down and kind of go through it one-on-one, we can definitely do that during my office hours from 3 to 5 today. But we are here in ECE 2372, and we want to actually write some Verilog code. So I guess the first thing we need is a logic circuit to work with. So I'm going to pull up OneNote here. So let's go ahead and draw like the simplest logic circuit we can think of. We're just going to have a couple of inputs. Let's call them A, B, and C. Let's just have an AND gate, which takes A, B, and C, and let's create an output. Let's call it F. And let's do an OR gate. Call that G. And we'll have that also take from A, B, and C. So we'll say that F is a function of A, B, and C, and is equal to A and B and C. And G is equal to also a function of A, B, and C. And that's going to be equal to A or B or C. So this is the circuit that we're going to go ahead and try and make. 3 inputs, A, B, and C, an AND gate, an OR gate, and then outputs F and G, where F is just the output of the AND gate, and G is the output of the OR gate. Any questions about the circuit we're going to try to build? Okay, all right. So let's minimize that. And as promised, for right now, I'm just going to do it in regular vanilla Notepad. I'm going to go and save that file as, I'm going to go to my C drive, ECE2372, and I'm just going to call it circuit.v. All right, so Verilog files have the extension .v, and we'll give it a name. I'm just going to call it circuit.v for my logic circuit. Obviously, when we do it in practice, we're going to use much more descriptive names, but for now, this will do the job. Devin asks, so I was wondering, since you included the first file into the underscore TB file, can you make them one big file? Yeah, we're going to come back around to that concept, Devin, but the short answer is you don't want them in one big file because you, well, now that I think about it, by my like entire career, by best practice, we've always separated them out. But now I'm kind of thinking maybe you could make them in one file. I'm going to say for now, don't do that. We're going to keep our logic modules and our test benches in separate files. But now I'm kind of curious, and I'm going to explore what happens if I treat them all as one file. Pamela asks, can you do what you just did again? I had to re-download Verilog. I just opened up Notepad and created a file called circuit.v. And yes, this is being recorded. So, Pamela, where do you need me to go back to? Okay, cool. All right, so let's go ahead and type some Verilog. By the way, if I now look in my directory here, I can see that I have a file, circuit.v, that is in fact 0 bytes. It has no data in it. It's got nothing. Okay, so let's go ahead. So Verilog logic circuits are just, they're modules. So we design a logic circuit by hand, and we implement it as a Verilog module. So it'd be module circuit. And then I'm going to open parentheses and close parentheses and do a semicolon, and then in module. Everything happens inside module and end module. Verilog doesn't do curly braces. So for example, a more modern language might do something that looks kind of like this, right? This might be really similar to something that you've seen in another programming language. Verilog doesn't do that. Instead, it uses begin and end statements. Liam says, wait, were we supposed to change the text file or .txt file to a .v file? Yes, absolutely. .txt file won't run, man. Here, I'll do that part again. Let me see. Don't save. I'll delete that file. Let me reopen Notepad. Hit Control S. I'm in ECE 2272. So yeah, Notepad defaults to. So I hit Control S to pull up the save dialog. I saved it in my ECE 2372 file. Verilog, I mean, Notepad wants to do it as a text document by default, but you can say, nah, man, I'm not doing that. And delete everything and type circuit.v. And even though it doesn't, so if I were to not include an extension here and just say circuit, and then look at my directory, it would automatically apply the extension .txt to it. That's no good. That's not what we want. Instead, what I want is to define that. So I'm going to say circuit, and I'm going to explicitly say circuit.v. Now if I run dir again, I've got my .v extension like I need to. This, by the way, is the part where I tell you that file extensions are a lie. No, you don't have to save it through Notepad. You can do whatever you want. File extensions don't mean anything, by the way. They are just little shortcuts. They're hints to give the operating system a hint as to which application to use to open. So a .doc file. How can we do it in VS Code? We're going to get there, but I want to do it this way first because I want to illustrate that VS Code is not necessary to do this. VS Code has nothing to do with Verilog. VS Code is just going to put some pretty colors on top of it. But it's important that you see that we can do everything just like this without VS Code. Because you're spoiled, because your CS professors let you use Visual Studio 2019. And so now we struggle to separate what the code is from the editor in your brains. So we're going to stick to the bare bones stuff for now. Pamela asks, how do I use the command prompt not for a user? I'm not sure that's even possible. You have to be a user. You have to be logged in. Yeah, right? So it didn't have an extension, so you had to tell Windows what to use to open it. File extensions have no effect on the bits that are in the file, right? Extensions just tell the OS what to use to open a file. Aaron says, oh wait, hold on. The admin prompt. All right, it sounds like some folks are maybe having some like individual specific issues. We should address those during office hours. Again, like I said, we're going to assume that you already know how to use the command line and do some stuff. I understand that that's not the case for everybody, and that's just fine, right? You've come here to learn. But for the sake of class, I'm going to say for those of you guys who are having like weird little issues, I would be super happy to go over those with you in office hours and address whatever is happening on your computer one at a time. And Aaron, yeah, I don't know what your thing is doing. So it just worked for me. Oh, actually, I know I just said that, but here's one addressed at Aaron. Who'd have thought a bunch of computer science majors would have so much trouble caused by Notepad. All right. That's what I mean, man. Visual Studio 2019 has spoiled you. Aaron, did you by chance do this? Did you just type in circuit.v and like forget to delete the extension here? For those of you who are watching this on YouTube after the fact and wondering what's happening, I'm just sort of watching this conversation happen on the Discord. Chris M says you have to use all file for it to work. It works for me when I just do even it as a .txt file. So that's kind of strange. But Connor's probably right. If you switch to all files and then specify what you want, it should work too. Okay. Yeah, it's basically the same thing. All right, so I'm going to go ahead and file, being able to save files with the correct extension under things you should already be able to do. But if you can't do, that's just fine. Don't feel bad. But come see me in my office hours, and we'll go over how to do that. But we're not going to spend more class time on it. Okay, so we've got our module, right? Module circuit that we've named sort of blandly circuit. The first thing we need to do is define what we're going to put into that file. Can I expand Notepad? What are you talking about? Like this window? How much larger do you need it, man? Are you like watching this video on your phone? I mean, all right, we'll expand the font. I need to be able to see all the pixels. We'll make it 26-point font. All right. Yeah, man, seriously, 2 monitors. Live your best life. Especially, Matt, are you a CS major? Then yeah, like you need to invest in like multiple monitors. Like I'm not gonna lie, I've got 1, 2, 3, I've got 4 monitors right now, and sometimes I think I need more monitors. You can never have too many monitors. It's always worth it. Okay, all right, let's go ahead and move on. So, because we're running out of time and we actually still need to do some things. So remember, this is the circuit that we're gonna build. It's got inputs A, B, and C. It's got outputs F and G. F is the AND gate, G is the OR gate. So the first thing we're going to do is inside these parentheses, we're going to lay out kind of like parameters all of A, B, C, F, and G. Notice that we're not going to make any extension or make any distinction between inputs and outputs yet, right? We're just going to say module circuit has nodes, has connections, A, B, C, F, and G. Now we'll define our stuff. So I'm going to call these our input declarations. Notice the double slash is, so hopefully you're familiar with comments from other programming languages. The double slash is the, how do we do comments in Verilog. So what I'm going to do is define them as inputs. So I'm going to say input A, input B, and input C. I could also, by the way, who uses comments? No one comments. All code should just be semantically rich and expressive. You could define them all at once by saying A, B, C, just like that. That would also be valid. Like this will achieve the same thing as that. It's sometimes considered good practice to do it vertically like this because a lot of times these inputs are going to be different size values. So you're just I was just kind of getting the habit of using separate stuff. Sorry, I was distracted because Connor said, I'm assuming white space doesn't matter. People that don't use, no, white space doesn't matter. You can condense everything together if you want to and say input A, comma B, comma C. but use white space. People that don't use white space are monsters, and they should be ashamed of themselves, and they write terrible garbage code. Be a good person. You could also, yeah, you could put it all in one line, man. I mean, who even needs anything, right? So let's just say input. I mean, you got to separate different words, right? Input C. Like if we're going to be crazy about it, let's just do that, right? There you go. That's how you can live your life. No, don't do that. Use white space. Use new lines. Be a good person. Write code that humans can read. Okay, so that's the inputs. The outputs are going to look a lot the same. Output declarations. We're just going to say output F and output G. All right. So that's inputs, that's outputs, that's good to go. Now we actually need to do our logic circuit implementation. Remember, F was the AND gate, G was the OR gate. So the way this happens is I'm just going to say assign F is equal to A, then the ampersand, and B ampersand C. So ampersand equals AND. And then for G, assign G equals A or B or C. The vertical bar equals OR. And there we go, man. There's our whole module right there, all in one beautiful place. So that is how we do the logic circuit itself. Are there any questions about that? Before we move on, we need to write the test bench now to actually make it do something. But we could send this to an FPGA or a programmable logic array right now. Augustine asks, how did I save the file? I don't understand. Yeah, Control S. Oh, I saved it here as circuit.v. Cool. Okay, so now let's go ahead and make the next one. So I'm going to create a new Notepad window here. I'm going to leave this guy over here. I'm going to put him right there. And now let's go ahead and do some stuff. No, Liam, they weren't. Well, they mean different things. Those are bitwise, so he has double ampersand and double bar. In this case, yeah, they would work, but for the wrong reasons. Those are called bitwise and an OR, which is its own thing, and we'll talk about what that is at a later date. So no, for now, when you're just doing regular logic gates, just the single ampersand and the single vertical bar. Otherwise, weird stuff will happen to you. Okay, so the first thing we need to do, remember, the whole goal of a test bench, right, is to make sure that our signal is working. And for us, we want to simulate it, right? We've done timing diagrams by hand, but we want to now have the computer create the timing diagrams for us. So the first thing we need to do is define what unit of time we want to use. So I'm going to write apostrophe timescale. No, Liam, that would be addition, man. Obviously. So yeah, plus means add in Verilog. Not in code, it's not, man. Try plus sign, man. It'll throw some errors. Hudson asks, how do you comment? Do that with the double lines. Okay, well, let's move on. Timescale. So I'm going to type timescale 1 nanosecond, 1 nanosecond. Now, there are a couple of things to unpack here. The first one is what's going on here with this 1 nanosecond, slash 1 nanosecond. The short answer is just do this forever and you'll be fine. 1 nanosecond slash 1 nanosecond. But it's the time unit slash the time resolution. Right? In class, when we did our timing diagrams, we said things like, well, let's do, yeah, coming back to that, Liam. Let's do the, every 10 nanoseconds a thing will happen, right? All we're saying is when we define a number for a time delay, as we'll see down here later, that is going to be 1 nanosecond of time. The time resolution won't really matter to us, but that just says that if it has to do any complex timing, it will round everything to the nearest 1 nanosecond. So 1 nanosecond slash 1 nanosecond is about the most basic as we can do. And yeah, excuse me, the symbol right here is the apostrophe, not the single quote, right? So it's not that, right? The apostrophe is the one that is up next to the tilde symbol on a sort of standard American keyboard. It's at like the top left above the tab key. So yeah, it's below the escape. So this, not that. Okay, so that's that. Make sure you use the apostrophe. That's our time scale. We're pretty much going to always just leave it as this, 1 nanosecond slash 1 nanosecond. Yeah, it's a good time. Okay, oh, we need to save this too. So I'm going to go ahead and hit Control S to save. And I'm going to say, by convention, what I do, let me grab all files so we can see. So I have my circuit V file, is I do the name of whatever I'm testing underscore TB for testbench.v. So if I go and look at my directory, now I've got my circuit.v and my circuit underscore TB.v, my testbench file. All right, the next thing we need to do is bring in the file that we're testing. So I'm going to say include, and in quotes, we're going to do circuit.v, the one that we're building. So those are the things you got to do right off the top. Now, a testbench module is itself a module. So it's module circuit underscore TB, but it has no input and output parameters. So we're just going to not even include the parentheses. We'll just include a semicolon and say end module. The next thing we need are our inputs, our outputs, and what we call the unit under test. Now for inputs in test benches, this is where it gets weird. We're going to say reg for register A, register B, and register C. We'll talk about what registers are later. Just know that in test benches, you use registers for A and for inputs, and what we call wires for our outputs, wire F and wire G. The basic premise for that is we need to be able to manually write values to our inputs, so we use registers for that, and then we want to carry values out of our circuit, and we use wires for that. We will talk about what regs and wires are in Verilog in more detail, but for right now, just know use regs for inputs and wires for your outputs. And then finally, for unit under test, if you've ever done any object-oriented programming, this is going to seem very familiar to you. The first statement is the name of the module. So we want to create an instance of the circuit module. Then we need to give it a name. We're going to name it UUT for unit under test. And then in parentheses, we're going to lay everything down. A, B, C, F, and G. Right? And as long as this matches that, I got no white space, then all will be well. So there we go. We created our inputs, we created our outputs, we've created our unit under test. We've created our instance of our circuit that we're going to apply signals to. The last thing we need to do is run the simulation. So to do that, we're going to say initial begin begin and end. Again, Verilog does not use opening and close brackets. So in a normal language, you might see something that looks like that. The Verilog version of that is the statement begin and end. And now we'll do some stuff. Let's go ahead and do kind of like a normal transition like we would do in a timing diagram where we're doing by hand. Let's set everything first to 0. So we'll say A equals 0, B equals 0, C equals 0. And then we're going to delay for some amount of time. So hashtag or pound or octothorpe, whatever you call it, 20, and in parentheses. So here, this is where that timescale business goes, right? We said the time unit is 1 nanosecond, and we're going to delay for 20 time units. So that means that we're going to delay for 20 nanoseconds. So we're going to set everything to 0, and then we're going to wait for 20 nanoseconds. And then let's set C equal to 1. So we'll transition C from 0 to 1. And let's go ahead and wait for 50 nanoseconds. And I'm picking these values just sort of arbitrarily. And then from there, we would expect to see our OR gate go to 1, right? And then next, let's see what happens to get our AND gate to 1. So to get our AND gate to go to 1, we need A and B to also go to 1. So let's just say A equals 1, and then B equals 1, and then let's go ahead and wait for 20 nanoseconds. So that's how that's done. And now we're ready to do things, right? So I'm going to say $finish to let the simulator know that I'm done. And then the last thing we need to do is create our actual waveform file. So we need 2 lines up at the top of our simulation. The first one is $dump file. So it says where we're going to dump everything. And we're just going to call that circuit.vcd. So VCD is the GTK wave waveform file. Liam asks, what happens if you don't specify the initial values of A, B, and C? What happens in that case is they're undefined, and you'll get like a red line until those values are created, right? So a logic gate can't do anything until all of its inputs are defined. So you would get some weird errors. I don't think maybe to next time on Wednesday, if we have time, we'll kind of illustrate what that looks like. But you'll get unknown values, and nothing will work until this very last one, and once we've given them all values. So you got to specify initial values for everything. Otherwise, stuff gets weird. So dump file just says, hey, let's create a file called circuit.vcd, and that's going to contain our waveform. And dump vars, basically this just says, hey, where am I going to get the data from? And it's going to be 0, circuit.tb. Basically this just says I'm going to get the data from my waveform file from my circuit_tb test bench, right? These are just boilerplate. You're going to do this at the top of every test bench simulation. And then when you're finished, you're going to finish. So that is it for creating the test bench. That is all the stuff. So we have a module. It's got all kinds of stuff in it. And we've got a test bench. And we're ready to actually run the simulation. We've only got about 3 minutes left. So let's take a look. We got our stuff. Now the commands here are pretty simple, but make sure you pay attention. We have to do 3 separate commands. So the first one is iVerilog itself. We're going to run iVerilog, option O, lowercase o. And then the file we're going to create, so circuit.vvp. VVP is an application that runs. Oh, so that's a good question. Liam asks, wait, but our file is named circuit.v, not VCD. That's correct. Here, so circuit.v is our Verilog file. What we're creating here is a waveform file, right? GTK wave, our waveform viewer, will use this file to visualize our circuit. So we're creating a new file, and that new file needs to have the extension .vcd. Yeah. All right. So iVerilog, option O, circuit.vvp to create a dot. So now we're creating a new file with a .vvp extension. That's a simulation file. And we're going to create it from circuit_tb.v. So we're going to use iVerilog. Don't worry about option O. We're going to create a circuit.vvp simulation file, and we're going to do it from our source, which is circuit_tb.v. Don't forget, we don't need to specify our circuit.v, because we've already included it. But by the way, if we didn't have that line, right, if we didn't have our include statement here, we would also need to specify circuit.v to bundle all of our code together. But a lot of times we have lots of different modules, so that's kind of unwieldy. So instead, we're going to keep our includes and do it that way and only run with this one file. So we're going to hit run or hit enter. And if you get no messages, that means there were no syntax errors. We didn't make any errors in our code, so life is good. But if you had syntax errors, they would have appeared there. So for example, let's say I forgot the semicolon here at A, and I ran it, and look at that, boom, I got some errors. A thing about semicolon errors, so it says the syntax error is at line 25. But if you actually go to line 25, which is right here, there's nothing wrong, right? If you're missing a semicolon, it will tell you that the error is at the next line. So it's always a good idea to be like, there's nothing wrong here. Go to the line right before it and be like, oh yeah, I missed a semicolon. And hit that. And it's all good. So let's run that again. And all is well. I'm going to go kind of fast because we were done with our time here. Next, we actually want to run. So we've created our simulation file. If I hit dir, now I've got a circuit.vvp file that has, it's 2.7 kilobytes. So that's a pretty substantial file. Now I want to run the simulation. VVP is the command there on circuit.vvp. And what it says is dump file circuit.vcd open for output. Basically, this just means that I don't know, that it worked properly and it created our .vcd file. So if I hit dir again, look at that. I've got a VCD file here. Now we want to run GTK-Wave. So you can open up GTK-Wave directly. So I can say GTK-Wave, and it will kick open GTK-Wave, and I can go to File, Open New Tab, and find my VCD file. But a better way to live your life is to just say GTK-Wave, and then give it the name of the file, circuit.vcd, and then it will open with our stuff already loaded. And then I'm going to come down here and you can hold control and select everything one at a time, or you can do shift and select them all and hit append. And then there we go. Unfortunately, I can't make this any bigger. But now you can go and look and see, all right, in the beginning, everything was equal to 0. That makes sense. Then here at 20 nanoseconds, I can look over on the left and say, all right, C is at 1, and G became 1, which is good. It's what we wanted. And then we waited 50 nanoseconds, so 20 nanoseconds to 70 nanoseconds. And then you can see that A and B both went to 1, and then F, which was the AND gate, also went to 1. Okay, so that's that. So Diet and Liam, sounds like you've got individual things going on. We can talk about those in a second. But are there any? So that's the gist. So we've done everything. We've installed Verilog. We've written our code in just basic vanilla Notepad, and we've created our simulations and gotten using Verilog in the command line, and we've even created our timing diagrams automatically. Are there any questions about that process other than I'm doing something, I'm getting a weird error? That's a thing you should bring me in office hours. If we change the timescale line at the top, would that represent time delay from gates? No. So there's really not going to be, when we do these timing diagrams, there's really not going to be any gate delay. So we're not going to worry too much about the propagation delay in the gates when we're doing our Verilog simulations. There's a way to do it, but we're not going to worry about it. So as you can see, all these gates are switching instantaneously. How would we implement time delays for gates? We could do it, but we're going to need, and it's actually not that hard. Maybe on Friday we'll get there, but there's a way to do it, which is kind of interesting, but it involves some advanced stuff, and we're not there yet. Cool. All right. Then that is it. We will pick up right here on Wednesday. We'll sort of take this code. I'll show you how to use Visual Studio Code to sort of do it in a more attractive, more concise kind of way. Visual Studio Code is great because it will let us, provide syntax highlighting and tabs. It also has a built-in command prompt, so we can run everything from Visual Studio Code and all that fun stuff. So we will look at how to do that and then do some more advanced Verilog programming on Wednesday. And then I think on Wednesday, you'll also get your first project, which will be something like, implement a multiplexer or a decoder or something like that in Verilog. So, yes, office hours are from 3 to 5. All right, and if there's nothing else, I'll see you guys on Wednesday. Thank you.